this centripetal force, it is provided by gravitational force. So Fc, here it is Fg, gravitational force. So like here I have shown example again for the what is the purpose of centripetal force in tether ball. So here if a body is moving like this, its weight is mg and tension in the string is T. So according to, if this angle is theta, then this component is T cos theta and this component is T sin theta. So the force which is centripetal force, it is provided by this component T sin theta. So what is Fc here? It is T sin theta. This is the repetition of previous, we already did. Centripetal force and inertia, we already noticed that the velocity is always perpendicular to the tangent to the this radius, tangent to the circle, and centripetal force and velocity, they are perpendicular for any object moving in a circle. So now we will come to know the centrifugal force, an external force required to make a body move along a circular path along the uniform speed. It is called centripetal force. So along the radius, this force is called centripetal force. According to Newton's third law, if a force is acting in this direction, then there is some force which should act in opposite direction. This force which is acting in opposite direction, it is called centrifugal force. So outward, a radial force experienced by an object when in circular motion, it is called centrifugal force. Centripetal and centrifugal, they are equal and opposite. Now we will discuss centrifugal force. Have you ever noticed that when a car makes a sharp turn, then you are pushed towards the outside edge of the car? This is because of the centrifugal force, because centripetal force is in this direction and centrifugal is in opposite direction. While it feels like there is force acting upon a body, but the centrifugal force, it is not a true force. It is because of the centripetal force. So here the another example for the centrifugal force. Suppose a box in the center. Here we have put some box in the center. So if we take the sharp turn, then it continues to move in the same direction while it moves in circular path. So suppose a box is in the center of the bed. As a truck travel along a straight road, the box and truck, they are both moving in a straight line. If the truck suddenly turns to the left, then box tries to keep moving in same direction. So while it seems like box is being thrown to the right side of the truck is actually turning under the box. Means the force which is acting, centripetal force is in this direction, but the centrifugal is in opposite direction. So it feels centripetal force and this box feels centrifugal force which is away from the circle. Centrifugal force, it is a fictitious force. It is not interaction between two objects. It is not a real force. So now we will come to the application of centripetal force, motion in a horizontal circle. Speed at which object moves, it depends upon the mass of the object and tension. So velocity is T r upon m, where T is tension, r is radius and m is mass. So T here it is becomes equal to the centripetal force. Now we will come to know the bend curve, like if a body is along moving in at some slope, then suppose this plane is at an angle theta with the horizontal plane, then the force acting on this body is its weight, which is vertically downward, and normal reaction, which is given by earth, is perpendicular to the plane. So its two component is Ny and Nx. So this force, this angle should be equal to V square upon Rg. Tan theta is equal to V square upon Rg, where V is the velocity of this car and R is the radius of the circle about which body is moving, and G is acceleration due to gravity. So this angle should be necessary if body is moving in the plane which is inclined to the horizontal surface. Banking angle, it is independent upon the mass of the vehicle. If a car rounds the curve at less than design speed, then friction is necessary to keep it from sliding down the bank. If the car rounds the curve at more than the design speed, then friction is necessary to keep from sliding up the bank. These are very important application for the centrifugal force. Centrifuge, it is a device which is used to separate light particles from the more dense liquid in which they are contained. For example, cream, it is separated from milk in the cream separator with the help of centrifugal force because of different type of cream is light and milk is heavy. So the more heavier thing, it is towards the center, and while this is away from the circle. In sugar industries, sugar crystal are separated from molasses. We know in the machines, washing machines, wet cloths, they are dried by the dry cleaner with the help of centrifugal force. And fourth one is centrifuges are also used to separate honey from the wax. So these are few examples, few application in biology. Like in the drug industry, it is also used to separate aspirin from the mother liquid by the centrifugation, and in blood cells it is also used, and in some type of analysis of drugs it is used for the biological purpose. Centrifugal is used for the biological purpose. Now we will come the motion in a vertical circle. Motion of a mass on a string in a vertical circle, it includes a number of mechanical concepts. First, it must satisfy the constraint of centripetal force to remain in a circle, and it must satisfy the demands of conservation of energy, as gravitational potential energy, it is converted into kinetic energy when the mass moves downwards. So now we will define here everything. Suppose first the body is at this point and it is moving in the vertical circle. So at here its potential energy is 0, but here it is having kinetic energy as well as potential energy. But when body reaches at top, then its velocity is 0, but its potential energy is highest at this point. So the gravitational force exerts a tangential force on an object like T is equal to mg v square upon rg plus cos theta. Here this term is centrifugal force, centripetal force, and mg cos theta, it is due to the tension in the string. So this is if a body with mass m, it is tied, at the lowest point A, its tension minus mg, mg is weight, is equal to mv square upon r, but at highest point it is in opposite direction. So, T plus mg is equal to mv square upon r. So, at highest point tension is 0. So, after substituting 0 plus mg is equal to mv square upon r. So, velocity becomes gr square root at highest point. So, now we will find out the minimum velocity of a body which it should possess at the lowest point in order to just loop the vertical circle according to the conservation of energy. Kinetic energy and potential energy should be same at each point. So, at the lowest point potential energy is 0. So, only kinetic energy is at point A, but at point B both energies are there, potential energy as well as kinetic energy. So, at point A it is half mv1 square, at point B potential energy is mg into radius 2r, kinetic energy is half mv2 square. So, v1 square is equal to 4gr plus v2 square, where v2 is gr. So, after substituting its value gr, it becomes v1 is equal to 5gr. It is a minimum velocity body should possess in order to just loop the vertical circle. So, next example, a car is travelling initially at 20 meter per second. It is moving 20 meter per second, then it stops at a distance of 100 meter. What was an acceleration? So, according to the kinematic equation, 2as is equal to final velocity square minus initial velocity square. Final velocity is 0 and initial is 20. So, 2 into a, s is 100 is equal to 0 square minus 20 square. So, acceleration becomes minus 20 upon 2 into 100, it is minus 2. So, minus here it signifies that its velocity is decreasing, that the body is at retardation, body is deaccelerating from point 1 to point another. So, next example is a disc with radius 50 centimeter. It is rotating at 600 revolution per minute. It comes to a stop after making 50 revolution. What is the acceleration? So, the first angular velocity is 600 and second is 0, and q, it is frequency, is 50 revolutions. So, 2 alpha theta is equal to omega f square minus omega naught square. So, after substituting all these values, we will come to know a, this is alpha, it is equal to minus 6.29 meter per second square. So, next example is 3 kg rock swings in a circle of radius 5 meter. If its constant speed is 8 meter per second, then what is centripetal acceleration? Centripetal acceleration is v square upon r, where v is velocity 8 meter and radius is 5 meter. So, the centripetal acceleration, it is becomes v square is 8 square upon 5, and force is m into AC is centripetal acceleration. So, force is 3 into 12.8, which is acceleration. So, force is 38.4 Newton. Thank you.